Use geometry to evaluate this integral and confirm your answer by evaluating the definite integral. So the first thing we should recognize that our closed interval is from 2 to 4, given by limits of integration, and our function f of x would be equal to 2x plus 1. So as you can see in the equation, our y is equals to 2x plus 1. Since this equation is in slope-intercept form, so we are going to use the formula y is equals to mx plus b. We have this linear equation, y is equals to 2x plus 1, where 2 is our slope and 1 is our y-intercept. So let's go and graph our linear function on a closed interval 2 to 4. However, we want the values of y when x is equals to 2, when x is equals to 2, and x is equals to 4. So let's begin substituting this x values to our linear equation. Y is equals to 2x plus 1. So here is it. Here is our solution. So in x is equals to 2, our y values is equals to 5. 2 times 4 plus 1 is equals to 5, and at x is equals to 4, so 5, and this, and our point located in here. So at x is equals to 4, so 2 times 4 plus 1 is equals to 9, so our value is equals to 9, and 9 is located in here, and 4 and 9, so the point is in here. And now let's graph this one. So and now the graph will look like that. So since that figure is a composite, so all we need to do is we need to break down it to fundamental shape. So we could break it down to rectangle and triangle. So this one, rectangle and a triangle. So it's not perfect, and it's not necessary to perfect. So now we need to do is to determine the dimension of each figure. So let's begin at the rectangle. So to find the area of the rectangle, so we need to have a length and its width. So the length is 5, from 1 to 5. That's our length. And the width is the difference of 4 minus 2. So 4 minus 2 is equals to 2. Since the area of a rectangle is equals to length times width, so 5 times 2 is equals to 10. And here is our solution of the two dimensions. So let's begin with a triangle. So the same as the rectangle, the base is 2, and then the height is difference. So the height is the difference between 9 and 5. So 9 minus 5 is equals to 4. And since the formula of getting the area of our triangle is equals to 1/2 times base times height, or is equals to base times height all over 2. So since our base is 2, and our height is 4, so 4, and 2 times 4 is equals to 8, and half of 8 is equals to 4. So is equals to 4. So let's add the two areas. 10 plus 4 is equals to 14. Let's now evaluate this definite integral. So the antiderivative of the integral 2x plus 1 with a closed interval from 2 to 4 is equals to 2x squared divided by 2 plus x evaluated from 2 to 4. And now let's substitute the 4 and 2 values to our x variable to our antiderivative. So here is the solution. So let's substitute first the 4, and same goes to the other side, the 2. So 2 times 4 raised to the power of 2 divided by 2 plus 4 minus 2 times 2 raised to the power of 2 divided by 2 plus 2. So let's cancel this numerator, the 2, and then the denominator, because this is going to be equal to 1, and same goes to the other side. So we have the remaining numbers. 4 squared plus 4, and 2 squared plus 2. So 4 squared is equals to 16 plus 4, and 2 squared is equals to 4 plus 2. So 16 plus 4 is equals to 20, minus 4 plus 2 is equals to 6. So 20 minus 6 is equals to 14. So that means that we did this problem correctly.